Dear colleagues, let me present to your attention the results of the research named The Concept of Efficient Utilization of the Uplink Frequency Resource of a Smart Factory 5G Cluster by IIoT Devices. Speaker is Viacheslav Kovtun. The implementation of Industry 4.0 in organizing smart manufacturing significantly complicates the design stage. The most flexible and parametrically responsive to the challenges of Industry 4.0 is the 5G platform, the permissible frequency spectrum for the application of which is strictly regulated, finite, and overloaded. Attention should be paid to the issue of horizontal control. The latter involves reasonable QoS policy-based organization of alternative service periods for different types of traffic based on their source, which the allocated frequency range. This research proposes an original analytically substantiated response to this relevant scientific and applied issue. Among the plethora of network technologies, the one most closely aligned with the aforementioned concept of horizontal control is license shared access control technology. In examination of the literature, reviewed a substantial number of papers dedicated to the simulating this technology. However, no analytical models was put forth in those works either. The analytical aspect of this issue has been inadequately explored, and to derive the model solution, cognitive radio technology was employed. This technology facilitated dynamic spectrum access. Nevertheless, the models analyzed under non-stationary conditions did not incorporate the influence of the periods during which the frequency band operates or remain inactive over time. Here we can see the object of the research, which is the functioning process of a 5G smart factory cluster, the monopolistic use of the uplink frequency resource of which is claimed by both human operators and IIoT devices. The subject of the research comprises elements of probability theory, Markov chains theory, and functional analysis. The aim of the research is to analytically justify the concept of efficient utilization of the uplink frequency resource of a smart factory 5G cluster by IIoT devices. The focus of our research is a smart factory 5G cluster, which a coverage zone limited by the cycle, which a corresponding diameter, centered at the location of the base station. Let's assume that within the velocity of the 5G cluster, IIoT devices are uniformly distributed, which attempt to transfer information messages to the base station, which corresponding intensivity. The duration of transmission is information messages by IIoT device is a stochastic parameter exponentially distributed, which the corresponding intensivity. We assume that the quality characteristic of the communication channel between the IIoT device and the base station are mostly determined by the distance between those entities. Here we can see that the uplink traffic speed for any end device in the investigated 5G cluster is a function of its type and its distance from the base station, which is represented by the expression 1. According to QoS, if the uplink connection speed that the base station can offer to response of an incoming request from IIoT device is lower than the guaranteed speed, then the base station switch to autonomous mode regarding to new uplink requests, during which all incoming requests from end devices directed to it are lost. The utilization of the state of uplink frequency resource of the 5G cluster at the time t, characterized by the function epsilon. The introduced stochastic parameters are sufficient to describe the operating process of the uplink frequency resource of the 5G cluster directly in the term of the state space Z, which is represented on the slide. Here we represent the parameter q, which characterizes the probability that the input request from n+1 n device will be accepted, given that the base station is already servicing information traffic from n devices. The specificity of the evaluation of the stochastic process Y allows us to classify it into the class of Markov processes. This enables us to move from the conditional probabilities 2 and 3 to stationary probabilities Q. Here we can represent the computationally efficient information technology for their calculation. For the instance of the process Y, we characterize its evolution in the metric of indicators such as the probability of implementing the uplink-autonomous mode, the probability of interruption of IoT device servicing due to the activation of the uplink-autonomous mode, and the average number of devices being servicing in the system due to the uplink-autonomous mode. Those metrics are represented by the expression 5, 6, and 7, respectively. We applied the capabilities of simulation modeling to evaluate the ordinary instance of a smart factory 5G cluster for the monopolistic use of the uplink frequency resource, we think is sought after by both human operators and IoT devices. The evaluation of the functioning process of the investigated instance carried out by the qualitative metric 6 and 7. To demonstrate the informativeness of the proposed metric, the calculation were made and their results are presented on Fig 1 and Fig 2 respectively. From the graphs shown on Fig 1, it can be observed that the quality indicator 6 is highly sensitive, as evidenced by the small increments in the ordinary scale. Additionally, it is evident that the power allocated to support information traffic in the frequency band omega increases, the interruption of servicing IoT device probability value sharply decreases due to the activation of the uplink-autonomous mode. The results presented in the figure 2 are intriguing. We will discuss this question a little bit later. So now let's move to the figure 3 and figure 4. From the Fig 3, it can be observed that the probability of interruption of servicing an IoT device due to the activation of the uplink autonomous mode begins to increase exponentially, which the corresponding R value. This phenomenon is practically independent of the parameter tau, but it is instead fully determined by the power value. This conclusion is supported by the graph presented on the figure 4. Finally, let's move to the results presented on the figure 5 and figure 6. Based on the information presented in figures 5 and 6, we observe trends that are characteristic of figures 1 to 4. So now is the time for conclusion. The article investigates the functioning process of a smart factory 5G cluster, where both human operators and industrial Internet of Things devices contend of monopolistic use of uplink frequency resource based on the defined quality of service policy. To analytically formalize this process, the authors have developed a Markov model. This model model reflects both the inherent characteristics of the studied process and the mechanism of adaptive power control, which considers the type of traffic being serviced by the base station at any given moment of time. Within the framework of the created model, a qualitative metric is proposed, capable to characterizing the evaluation of the studied process. Instance, through a set of indicators such as the probability of realizing uplink-autonomous mode, the probability of interruption of IoT device servicing due to the activation of the uplink-autonomous mode, and the average number of devices being serviced in the Smart Factory 5G cluster during the implementation of the uplink-autonomous mode. Thank you for attention, dear colleagues, and I will be glad to answer your questions.